Welcome to this class today. If this is your first time in this channel, please like and subscribe. God bless you. Amen. All right, so today we want to look at uh, moving from single agent to many agents, from one agent to multi-agents. So that's our lesson today. So at the end of this lesson, you will learn how to move from designing single agent to designing multi-agents. So what we are looking at is building applications, agentic system applications for enterprise. So this is what we have in our first slide. The golden rule: start with one agent. So, before you build an agent, you must have a problem that you want to solve. So you move from problem to designing. So from business requirements or business problem, turn business problem into technical objective, or turn business objective, which is the business problem, into technical objective. Then you design the architecture, and then you build the architecture, and then you test the system, and then you deploy, and then you monitor, and then observe, okay, continuously, just like that. So the golden rule: so when you collect business problem or business objective and you study it, so you don't just move to designing 10 agents or 20 agents. No. You have to analyze it. You have to or study what you have. If it is what common machine learning, which is a traditional model, can solve, why do you need AI? Okay. If traditional model cannot solve it and just common generative AI can solve it, why do you need agents? Okay. And if generative common small language model, which is generating AI, common prompt and building, cannot solve it, then you move into single agent. So if it is what single agent can solve, then you design single agent. It is when it is complex and needs customization that you now start moving into multi-agent. Okay, so this is what it is, what was taught in AB 100, Microsoft AB 100, Agentic System Architect. So when you collect a business problem, if it is what you can simply develop in Copilot Studio, you don't need to take it to Microsoft Foundry. So Microsoft Foundry is used for designing multi-agent system. It is used for designing custom agents. So if you just want simple assistant, chat assistant, or simple workflow, you can easily define it or design it or build it in Copilot Studio. So this is how this works. So if you have a simple task, so if the business objective is simple, easier to build, manage, iterate, and it is just on a single prompt or two sets, then use more single agent. If it is cost efficient, fewer model calls, and zero orchestration, no orchestration or coordination is required to keep operational work flowing, use single agent. So reduce latency. No time is lost in inter-agent communication. So if you don't need inter-agent communication, also use single agent. Then linear debugging. One agent owns the full flow, making it significantly easier to trace error back to specific prompts or to outputs. So these are the simplicity and the benefits of implementing single agent when the business requires it. So why simplicity is your greatest competitive advantage in early stage agentic development. So agentic single agent is easy to monitor, easy to observe, easy to deploy, easy to build, easy to manage, and easy to integrate. Okay, so because it is just one communication layer, no inter-agent communication, or all you just need is routing and tools and tool calling. So complexity triggers. So when the single agent is overloaded, okay, when it is no longer reliable. So when when single agent is used for multiple domain, like the agent used in IT operation is being used in finance, is being used in procurement, used in supply chain, used in HR, then it will be diluted. That is confusion, because even a single human being cannot function as an IT manager, procurement manager, HR manager, and finance manager. No, it's not possible. So that will cause confusion in the cognitive system of the agent. Then parallel processing, when multiple subtasks need to execute simultaneously, single agent cannot handle this. So you need multi-agent system here. So case study, the system tool logistic agent bottleneck, operation tools, like manage inventory, track shipment, arrange shipping. Optimization tool, optimize warehouse, forecast demand, optimize cost, crisis and risk, manage disruption, handle compliance, manage special. Communication, send logistic response. One agent cannot handle this. Okay, this will be too much for one agent to handle. You need multi-agent system here. So the composition into specialist. So, or you can have this kind of agent, inventory agents. The responsibility will be levels, forecasting, warehouse audits, and the tools it can call are manage inventory, forecast demand, optimize warehouse. We have transportation agents. The responsibility will be shipping, delivery, disruption management, and the tools it can call are track shipment, arrange shipping, manage disruption. Then you have the supplier agent, performance audit and regulatory compliance will be the core responsibility of that. And the tools it can implement are evaluate suppliers and do compliance. You can see the separation of concern into 3 agents. Imagine you design one agent to handle inventory, transportation, supplier, and call all these tools at once. You'll be building confusion or chaos into the system. Supervisor agent as the central router. So when you have a multi-agent flow, you need a supervisor agent which will orchestrate all the tasks, route all the responsibility to the agent required, or route all tools, tasks to the agent, and then connect agents to tools. So this is why agentic system orchestration is very, very important when multi-agent system is the use case. So, or you must design for intent recognition, routing logic, and workflow control. All this logic must be properly designed. Then comparison coordination patterns for agent teams. So, manager coordination. So the manager agent supervise all the works, all the tasks, all the tools, and everything goes through the manager agent. We have democratic manager coordination, where one manager, one orchestrator manager coordinate all the tasks. We have democratic coordination. Agents have equal power and reach consensus best for collaborative system where fairness and robustness matter. And then we have hierarchical coordination, where you have the CEO, CTO, manager, worker. And then you have the actor critique, where specialized loop, or where one actor generates a plan and the critique agent score or rejects whatever the actor agent generates. So quality fair the actor critique loop. So you have the actor node, the critique node, the approver, and the refinement. Then we have the emergent swarms. So this is collection of many agents acting together, working together to achieve a common goal, just like you have in organization. So this will use a decentralized control or decentralized architecture, this decentralized orchestration. This will be very robust to design and the scalability, because swarms can grow to hundreds or thousands of simple agents. And then this ideal use case for this is distributed search, sensor network, monitoring, and edge computing. Then agent to agent protocol and agent card. So agents talk to each other through agent-to-agent protocol, not through tools. Agents communicate with external system, like website, like API, like database, through tool calling, routing. Then agent-to-agent communicate through agent protocol. So these can be designed using agent card, which are JSON structured objects defining an agent identity and capability. We have the handshake. Before exchanging data, agent validate versions and capability support to ensure capability. JSON RPC, which standardized requests and responses allow agents built on different stack to interact seamlessly. Future is why agent-to-agent enable dynamic ecosystem. It requires robust security measures for authorization, trust, and rate limiting. Okay. So broker decoupling. So this is another layer of communication. So Redis, Kafka manage distributed task routing and system resilience. So PubSub, one agent publishes, another subscribe. Parallel consumers, all agents just queue for tasks and collect tasks concurrently. And the benefits, this provide loose coupling, allow message replay, enable independent agent scaling, and based on load, and can be durable. So if especially crashes mid-task, the broker retain the message for a retry, prevent data loss. So PubSub is very, very important. So you can make your agent operate through event-driven architecture using publisher and subscriber. Session-based array agents. So we have an isolated state, array session manager, sequential processing, and scalability. So starts from managing state and avoiding memory contamination in high concurrency multi-agent environment. So start with isolated state, extend to session manager, to sequential processing and scalability. Durable orchestration via workflow engine. So this can be implemented by using state persistence, false tolerance, using human in the loop, and feasibility. And then we have automated design of agentic system, ADAS. So this is the engine that is used for generating agentic system design pattern. So you move from manual architectural design to meta agent optimization. So the agent generates pattern and update the pattern whenever the system needs upgrade. So you don't design agent pattern manually. No, the meta agent system generate the pattern and optimize the pattern continuously. But it has advantage and disadvantage too. So meta agent search, MAS, is an algorithm that proposes new agent architectures, write their code, and test them in your system. So the search loop architecture candidates are tested for fitness using bootstrap confidence interval. The archive. Successful designs are stored, allowing future generation to build a past successes, and their continuous improvement. The system evaluate performance, debug designs, and refine prompts without human intervention. So it's automatically just generate the agent, optimize them, refine them, and replace all these old architectures with those new architecture without any human intervention. So that is why it can be dangerous if it is not properly designed. So the evolutionary part of AI agents, selecting the right agent coordination and infrastructure approach based on your specific scaling need. So approach, key idea, best use case. Single agent, use single agent for monolithic container. Example, best use cases for prototyping and simple tasks like chat assistant, meeting assistant, and so on. Agent-to-agent protocol, used for discovery and JSON RPC. Then best use case is for dynamic and open ecosystems. Okay, advanced system, message brokers, PubSub, async messaging. Example use case, best use case is for distributed task routing, used for distributed system. Actor framework, key idea, stateful sequential actor. Best use cases for precision scalability, workflow engine, durable orchestration for production grade processes. Okay. So this is the end of this lesson, guys. Hope you have achieved something. You can now move from building single agent to building multi-agent and orchestrating them together, designing communication using distributed message brokers like for Kafka, or using agent-to-agent protocol for swarm or multi-agent system, and for automated generation of design of agentic system design, you use a meta agent search. So thank you. Please like our channel and subscribe to get the next video when we post it.